Okay, now that we've gotten past the creation of different sprites in part 3A, 3B is the video where we're going to add a behavior to our second sprite, the food. So this is where we're going to see that the second sprite actually has a purpose. So we've got our first sprite as the snake head. Let's just turn the animation on again. Okay, so I can move the snake head around. And what I'm going to want it to do is I'm going to want the snake to be able to eat the food. Right now it doesn't do anything with the food. I want the snake to be able to eat the food, and that's going to be part of our game. So I'm going to ask you to think about, and you might want to pause the video once I ask this question, but think about how would you describe what the food should do as a sprite and when it should do it for this game to work. If you hopefully you know enough about the snake game and how the snake game is supposed to work. But think about what you want the food to do and when it should do it. Okay, so here's how I would describe what the food should do and when it should do it. Let's handle when first. So when the snake head collides with the food should do something, because that's when the snake head collides with the food, we are imagining that the snake is eating the food. Okay, so when the snake head collides with the food, what we do is the food is going to disappear because it gets eaten, but then the food is going to reappear somewhere else, because that's the way this game works. The snake is always going to have some food to eat, but it's just going to be somewhere different on the game board. Okay, now obviously if the snake ate some food and then some food appeared somewhere else, then that's different food in the way we're imagining that what this game is supposed to represent. But we have one food sprite, and we're just going to reuse that sprite for every time that there is food in this game. So there's really, in reality, just one piece of food, and we're just going to move it around and make it look like that it's a new piece of food. So what really happens to the food sprite is it disappears from one place because it's eaten, and then it reappears in another place ready to be eaten again. Okay, so that to me is how I describe the behavior that the food is going to engage in. So let's say after we've set up the sprites, let's add a section for food behavior. We actually only have one behavior for the food, and I'm going to make a function for it because we put all of our behaviors in functions. So I'm going to say define move food as our behavior. And I'm actually going to, let's just say define move food right now. Okay. And let me write in comments what moving the food looks like. So hide food. No, hide food. And then change location of food, and then show food. Okay, so this is what's going to happen. And in order to do this, now I can start adding the code in here that does these things. So what I've done here with these comments is this is called writing pseudocode. So I'm actually, when I verbalize what I want to happen in my program and then start to write it as if it's kind of like commands, but it's not quite in Python yet, that's called pseudocode. Pseudocode is not real code, but it's kind of a step in between your idea of what should happen and what it will look like in Python. And what you're actually doing when you start to break these things down step by step, that's a process called functional decomposition. It means decomposing something that's more complex into the pieces that will allow you to get it to function the way you want it to. Another phrase for that is writing pseudocode. And eventually you end up with code if you are able to keep breaking it down until you can express it in Python. So luckily, hide food is something simple enough that I can express it in Python. I will take the food object, the food sprite, and say, remember this is a turtle, so I'm going to hide turtle on the food. And showing the food is just as easy. I can say food.showTurtle. So notice that one advantage of writing some pseudocode is that I can actually write the code that goes with the different parts of it out of order. Because I know how to hide the turtle and I know how to show the turtle, I can do what's written in these comments because I know how to write the code for it before I start to think about changing the location of the food. Okay, but I also know how to do that. It's food food.goto. So that moves the food. As long as the pen is up, then this isn't going to draw a line, so that's good. So I'm going to go to, and then I need an X and a Y location, which I don't know. I guess I need numbers for that. And now I'm realizing I'm running into a different problem. I can give it a location, like I can say -50 and in X and 100 in Y. But then I just realized, well, let's do that, 50 and -100. That when I do this, every time I move the food, I'm moving it to the same spot. Ideally, what I'd like is for the food to move to a random spot each time. But let's talk about that some other time. And let's right now just be happy that we are able to move the food to some location and not worry that it's the same location. All right, let's run the program to see if anything's changed. Nothing's changed. And nothing's changed because even though I've created this behavior in a function, it's not called anywhere. Remember I said that there were two parts to this. There was one, what do I want the food to do? And two, when do I want it to do it? So I want it to do its thing when the collision triggers it. And that, of course, means that we have to program in the collision to trigger it. So I cut out part of the video here where I tested the move food function by putting it in the condition that got triggered when the snake head hit the wall. And so I'm going to resume the video from where I decide to actually add the check for the snake head colliding with the food. And so you're going to see a call right here with the collision with the wall being removed by me, and I didn't want you to be confused. So when I think of the condition that needs to happen for the behavior to be triggered, sometimes I just think of what I want to call that, and then I imagine, that I need to write a routine that can check whether that condition has occurred. So we already have a routine or a function that checks if we have collided with the wall. So what I want to do is the same kind of thing, but I don't want to check if we've collided with the wall. I want to check if we've collided with the food, or let's see, we can call it if snake eats food. So if the snake eats the food, then we want to move the food. So you can see that I've kind of written this as if, so we can take this out of here now because we don't need that anymore. So I've written this as if we already had the function. If I run this, it's not going to work because it immediately crashes, because it's going to tell me that it's not a defined function. I haven't defined it yet. So I have to make that function, but I already have the code that calls the function. Now I just have to make the function. So let's go and see where we should add this function. So we've got a function to check whether the sprite has hit one of the boundaries. Let's add a function here. I'm just going to put a comment in here. So function to see if the snake head has collided with the food, and what we called it was snake eats food. So we want to write this similar to the way that we wrote the collision with wall. And if you remember when I wrote that, that was a function that returned a value. So we defined collision with wall, and then we checked a bunch of things, and we returned the state of whether it had collided or not. In other words, the true or false state of whether there was a collision. So for us here, what we're going to do now is we're going to define fed. Fed is what happens to the snake after he eats the food. Snake, what do we call it? Snake eats food? Maybe we should call it snake ate food. I don't know. If the snake ate the food, you know what? Let's word this as if it's a question. That way, actually, so snake. We're going to think about this thing being true or false. So if we say snake ate food, we can think of it. Snake ate food is either true or false. I think that's the way to write this. Okay, snake ate food true, or snake ate food false. We know that the end of this we're gonna run a return either true or false, and we're gonna call that 8. So we're gonna use a variable called 8. So we're going to start out 8 equals false. We're going to assume that the snake did not eat the food. So now we're going to check. So I'm going to write some pseudocode here. Check if snake is close enough to the food that we can consider it a collision. Okay, so we want to check if the snake is close enough to the food that we can consider it a collision. Now there's a function in every turtle that allows you to check the distance between two turtles. And that is called the distance function. So it returns true if, it returns, So it returns the distance given to turtles. And here's how it works. So if we've got the head turtle, we're going to actually print this out so we can see it. So print head dot distance, and then you send in food. You could also say food dot distance and send in head. It doesn't matter, but it's part of every turtle. Every turtle can check its distance to another turtle. So if I put this print statement in, what's going to happen is that every time it calls snake ate food, it's going to print out the distance between the head and the food. And so we can get an idea of what it looks like for those values as they scroll up the screen. And then we can decide whether we're close enough, whether we should consider it to be a collision. So it's just going to keep calling this over and over again in our function, in our program. If I run the program, it's always going to return false. It's always going to say the snake did not collide with the food. But we're going to run this just so that we can see what those values are. So if we run the program, You see the numbers scrolling up. So those numbers are pretty big right now, but the closer that I get to the food, those numbers are going to get small. So I'm going to do a very close pass. Actually, what I'm going to do is I'm going to click stop when we get really close, and we can see if I think that's the moment that it should collide, then that's when I'm going to click stop. Okay, so that actually, there were 3 ticks before I was able to stop it. It looked like it kept moving. Right now it's really right on top of the food, but it's saying that that distance is either, it could be actually closer to 7. So it looks like 15 is probably close enough for this to be considered a collision. So instead of printing out, this was a test print that we did in order to get some data about our program. So what I've done is, now I've used this to figure out that 15 is probably close enough for us to consider this to be a collision. I picked a number 3 back because I don't want it to have to be right on top of the food. I want it to be right when it touches the food. So let's, instead of printing this out now, what I want it to do is actually we can keep these parentheses. If head.distance food is less than 15, then 8 equals true. Okay, so now what's going to happen is 8 is going to default to false, but if the distance between the head and the food is less than 15, it's going to set that to true, and it's going to say that the food was eaten, and it's going to return true, and that's going to move the food. Let's see if it works. So here's our snake and our food. Right now I'm staying down here, but now let's go. And we did it. There was a delay, a noticeable delay, but we got a collision with the food. Now if we go by it like that, it wasn't triggered. So 15 isn't getting triggered there. So we can test out, right? We can test this out to see if we like the distance that's being used. And even though, so there it was actually moved to the same place, because our move moves the food to the same place over and over again. So the third part of what I said I would handle in this video, in this third pair of videos of this pair. Anyway, the third feature that I said I was going to handle was adding scoring. And I'm going to make this really simple. So this isn't going to take any time at all, because I'm just going to add a score variable to this program. Score equals 0. So the reason I mention this as a separate feature, even though I just was able to basically add it by saying score equals 0. I mean, let's increase the score every time we run into the food. We're going to score equals score plus 1. So that's like one time we ate the food. Every time we eat the food, we increase the score by 1. A lot of games don't add ones. They add things like 100 or 1,000 because it's more exciting for games. We're going to just start out by adding 1 here. And that's how we're going to count our score. And then we can even print the score. If the snake eats the food. So when we run it, if we've got a collision, oh, I'm having trouble hitting the food. Okay, so that's 1. So now I have a score of 1, and then you can see I actually, because the food didn't move, I hit it multiple times there. So we have a score and we're keeping track of it. We're not displaying it on the game screen, but we have a score now. And those are the things that I wanted to show you in this video. So as with the last video, I'm going to give you one thing to think about. And that is, what would you do? So right now our food is moving, but it's very boring because it moves to the same space every time. What would you do in order to get the food to move randomly somewhere in this space every time instead of to the same place every time? So I'm going to make this code available to you. There'll be a link in the video description, and you can take this code or modify the code that you already have, and then change the way the food is working so that it goes somewhere random every time. Good luck with your problem solving, and I'll see you in the next video.